In this lecture, we study the topology of negative feedback. So, there are 4 types of negative feedbacks are there. One is voltage series feedback, voltage shunt feedback, current series feedback and current shunt feedback. Now, for this how to draw the diagrams that we will see in this lecture. Now, this is a voltage series feedback. So, how to draw the topology or diagram for this network. Now, already in the feedback amplifier, what are the 2 major important blocks? One is amplifier circuit. Now, here I am taking the amplifier, and the next one is feedback network. Now, amplifier is having the gain A and feedback network is having the beta. Now, here in this voltage series, voltage is the output sample. So, now here in this heading, the first term indicates the sample and the second term indicates the mixing. Now, here it is mixing, input side. This is nothing but output sampling. Sampling. So, now output we have to take what? Output side what we need to take? Voltage as a sample. So, for voltage sample, current sample, how to take the connection I have explained in the block diagram. Now, from the amplifier, now this is the load and here the V0 voltage is available, here V0 voltage is available. The same voltage we need to apply at the input of the feedback circuit. Now, for that what we need? In the shunt connection, voltages are same. That is why we need to apply the shunt connection. Now, here I am applying and here also I am applying like this. Now, if I am putting dot means what? No need to use the jumper. Here dot means connection is there, here also connection is there. Here dot is not indicating means what? There is no connection over here. Now, this is nothing but a shunt connection. Whatever the voltage is available here, the same will be available here. Now, voltage we have taken as a sample and input side mixing is series mixing. Now, in a series mixing means what type of source we need to take? Voltage source we have to take. Why we need to take voltage source? That I will explain now. Now, here we need to take the Vs, voltage source. Now, this is nothing but a Vf and here it is what? Vi. So, here we are mixing. So, when can signal can be in a series, voltages are can be added or subtracted, but in a series currents are same. Similarly, now if you take the shunt connection, in the shunt currents are added or subtracted, but voltages are same. Now, in input side we are doing the mixing. Mixing means what? Adding or subtracting we have to do. Now, how if we are taking a series connection, in the series connection voltages can be added. If my feedback output is voltage, then I have to take the voltage source. Now, here Vi is equal to, what? Vi is equal to Vs minus Vf. Why? Because all are these are we are discussing about the negative feedback circuits. Okay, this is a circuit diagram for the block diagram for the voltage series feedback network. Similarly, we have to draw the diagrams for the remaining 3. Now, this is the voltage shunt. Now, in this what is voltage? Voltage is nothing but what? Output sample. This is the output side. And shunt is nothing but an input side. Now, this is an amplifier again. I am not writing amplifier feedback network, just I will represent with the A and B. Now, this is an amplifier and this is the feedback network. Now, output is same, voltage means what? Here again we need to take the shunt connection. Here V0 is available. But input side is what? Input side also shunt connection we have to do. So, shunt connection means what? Like this. Now, in the shunt, which signals can be added or subtracted? In the shunt, voltages are same. So, you can't add the voltages over here. So, only currents can be added. So, meaning is what? Now, here this is the IF signal and this is the II signal and here we are taking the current source, that is nothing but a IS. So, this II is equal to IS minus IF. So, this is the voltage shunt. Voltage shunt means what? Output is voltage and input is current. Now, this is the diagram for the voltage shunt. Similarly, we have to draw the diagram for the remaining 2. Now current series means what? Output sample is a current and input side we have to mix in series. So now here for that what I am doing, I am taking the amplifier circuit and a feedback network. So output is current means what? I have to take this series connection. So whatever the current it is flowing over here, the same current is flowing here. So same current is coming. So our current is taken as a sample signal. Now applied to the feedback network. Now here input side we have to make this series connection. Series connection means what? Here this is the series connection. Now if we are making the series connection means which source we need to apply? Here we have to apply the voltage source. Voltages can added or subtracted in series. In series currents are same, that's why you can't take the current in input side. Whenever you are taking the series, that time you have to take the voltage source. This is Vs, Vi and Vf. So plus minus. Now here it is minus plus. So negative feedback we applied. So Vi is equal to Vs minus Vf and output is current. So this is about the current series. Next one, current shunt. So in a current shunt, output is sample is current and input side shunt connection we have to made. So here this is an amplifier and this is the feedback network and here output side is current. Current means what? Series connection we have to make. And this is I0 current, the same current is flowing over here and input side is shunt connection we have to make. So shunt connection means what? This. So in a shunt which parameter can be added or subtracted? Only currents can be added or subtracted. That's why now I am taking the current source, this is Is and here it is flowing the II and this current is nothing but a IF current. So now II is equal to Is minus IF. This is about the current shunt feedback network. So these are the 4 topologies and these are the block diagrams of the current 4 different types of topologies. Now we will see the what happens after applying this feedback. So different feedbacks after applying this feedback, what happened to the different parameters, now we will see here. Voltage gain, this voltage gain already we have derived, that is same for all feedback network, that is nothing but what? Voltage gain is what? AF is equal to A divided by 1 plus A beta. This is same for the all 4 different types of feedbacks. Now coming to the bandwidth. So bandwidth will be increased. Now bandwidth after the feedback, bandwidth with feedback is equal to bandwidth into 1 plus A beta. Now wherever the increase factor is coming, increase word is coming, there we have to multiply with 1 plus A beta. Wherever decrease is coming, there we have to divide with the 1 plus A beta. This is called the 1 by 1 plus A beta is the sensitive factor. Now input resistance, output resistance is different for the different feedback networks. So these we are going to derive in the next session. Now coming to the distortion and noise, both will be reduced in the all 4 feedback networks. Now coming to the input resistance, output resistance, already in the case of amplifiers we have seen that voltage amplifier input resistance is how? Input resistance should be high. By applying the negative feedback, further it will increase and output resistance should be low. By making the feedback, so further it will reduces. So similarly now here further it will be reduces in the case of, now voltage series is nothing but what? Voltage amplifier. Now current shunt is nothing but a current amplifier. Now coming to the voltage shunt, output is voltage, input is current. So output is voltage, input is current means what? V by I is nothing but what? Trans resistance. This is nothing but a trans conductance. Why? Because current series, output is current, input side is voltage. So I by V is nothing but what? Current conductance. These are the 4 different amplifiers. Already in the voltage amplifier we have seen that input resistance is greater and output resistance is less. So with the negative feedback, what happens, input resistance further increases, output resistance further decreases. Similarly, in the case of current amplifier, input resistance should be less and output resistance should be more. With the negative feedback, further it decreases and further it increases. So, and in the case of trans resistance, both the values should be less. With the feedback, further reduces. In the case of trans conductance, both the values are more. With the negative feedback, further increases. Now these we are going to see, and these we are going to derive in the next lecture. Thank you.